evaluate each expression. So when a question says evaluate, that means you need to come up with an answer. So we need to figure out what this is equal to as just a single number. So again, what we can do is we can do log laws. We know a 3 out in front lets us bring that in as an exponent. And subtracting for logarithms, the log law says we can divide. So we have 6 cubed over 72. Now you have options here for solving this, and either you can multiply the 6 cubed out and get 216 and then simplify 216 over 72. But sometimes when you have a non-calculator question, it is easier. 6 cubed is 6 times 6 times 6. 72 is 6 times 6 times 2. And then things nicely simplify. So instead of multiplying it out and have to do 216 divided by 72 and reduce it, if I just write 6 cubed is 6 times 6 times 6. And 72 is 36 times 2, and that makes it 6 times 6 times 2. Then I can cancel it out, and then life becomes a lot easier because 6 divided by 2 is 3. Now we still have to come up with a number for this. So remember that logarithms solve for exponents. So when I have log 9 of 3, I'm thinking 9 to what exponent would be 3? If you see that right away, you can just write the answer. So if you see that right away, you can just go equals and write the answer. Okay? I'm perfectly fine with that. I'm not going to tell you what the answer is right now. If you don't see that, then you could do the following. You could say, let x equal log 9 of 3, and then change it to exponential form. So the base is 9, the exponent is 3. And we solved these before. If we get the base is the same, I'd always write, so 2x has to equal 1, and x would have to equal a half. So the answer to log 9 of 3 is a half. What is an exponent of a half? That's a square root. Right? So you might have been able to just if you thought 9 to what power is 3 and it needs to go down, you could think, oh, what fraction would work? If it's a half, that's a square root. And you might have been able to just do that directly. But if you can't do it directly, you can introduce x and you can use the exponential form to be able to solve it. So one of the things that's really important in logarithms is to be able to switch back and forth from log form to exponential form to log form. Because sometimes when you can't figure it out in log form, you might be able to figure it out in exponential form. Now part B, we have 2 log 4 of 6 minus 3 log 4 of 3 and plus log 4 of 12. So again, each of these individually, if I look at them, I don't know 4 to what power is 6, I don't know 4 to what power is 3, and I don't know 4 to what power is 12. So since I don't know those separately, maybe if I combine them as a single logarithm, I use my log laws and say, first of all, I can put in all the numbers out in front as exponents. And if you have single logs adding and subtracting, you can use the product rule and the quotient rule. So whichever ones are positive, which are the one with the 6 squared and the 12. Those will be in your numerator. And whichever ones are negative, that'll be the 3 cubed, will be in your denominator. And once again, I'm going to expand these out. 6 squared is 3 times 2, 3 times 2, and 12 is 3 times 4. I'm going to do that. Instead of multiplying it out and trying to do 36 times 12 in my head, I'm going to expand it like this with its factors. And then I have 2 times 2 times 4, which is 16. This one, I don't think we need to do that other method. I think you can figure out the exponent right away. It's equal to 2. So you can circle question number 13.